Welcome to this video on factoring quadratics. This is going to focus on quadratics that don't have a 1x squared out front. So when we see a problem like we see on the screen currently, what we're going to do is look at the factors of the number attached to the x squared. It could be 1 and 35, or it could be 5 and 7. We're also going to look at the factors of the whole number off on the side. So we could have 1 and 12, we could have 2 and 6, or we could have it as 3 and 4. Now what we are trying to do is figure out how these factors were going to look so that when we multiply them together and FOIL it out, we get the quadratic that we have on the screen. In order to do that, we're going to look at pairing one set of factors from the x squared term with a set of factors from the constant term. And we're going to look at multiplying things together. So 1 times 1 would be 1, and 35 times 12 is going to be a rather large number. 35 times 12 is 420. Can we add or subtract 1 and 420 to get us the middle term, which in this problem is just a positive 1? And unfortunately that doesn't work. The question is 1 times 12 is 12, 1 times 35 is 35. Can we add or subtract 12 and 35 to get 1? And that doesn't work either. Now in class we gave the heads up to look for starting at the factors that are closer to each other. So let's jump down to the highlighted numbers we currently have. 5 times 3 is 15. 7 times 4 is 28. We can't add or subtract 15 and 28 to get 1. But if we did 7 times 3, that's 21. 5 times 4, that's 20. That works. So we're going to put a 5x in one parenthesis and a 7x in the other parenthesis. Doesn't matter which is which. But now it does matter where the 3 goes and where the 4 goes. So what we wanted was 21 and 20. To get 21, we need 3 times 7. So we'll put the 3 right here because then we multiply the 7 and 3 together when we expand or FOIL those parentheses. The 4 is going over here then because when we FOIL, 5x times 4 would give us the 20x. We want it to be a positive 1 in the middle. So we want the positive to be on the 21 and the negative to be on the 20. As we said in class, please circle your final answer, but then FOIL to check. So 5x times 7x is a 35x squared. 5x times a negative 4 is a negative 20x. 3 times 7x is going to be 21x. And 3 times a negative 4 would be a negative 12. When we combine our like terms, it's going to be the exact expression we wanted. 35x squared plus x minus 12. Let's look at our next example. Again, it has some number attached to the x squared. That number isn't 1. So we're going to start by looking at the factors of 6. And we'll look at the factors of the 18, which is the constant term. Make sure you're not overlooking any factors. As we said in class, we're going to look at the factors that are nearest to each other in order to come up with something. So if we pair those two up together, 2 times 3 is 6, 3 times 6 is 18. Adding or subtracting 6 and 18 is not going to get us 23. And then we've got 3 times 3 is 9, 2 times 6 is 12, and a 9 and a 12 cannot add or subtract to get us 23. And by the way, we really do want to subtract these since the sign on the constant term is different. What if we paired these up? 2 times 2 is 4. 3 times 9 is 27. 4 and 27, if we subtract them, looks like it might give us the 23 that we would need to have. So let's look at using this as the set of factors. Writing it out, we know that the two first terms are going to be a 2x and a 3x. Now what we said was 4 and 27. So we need to multiply 2 by 2, and we need to multiply 3 by 9. We want the 23 to be negative, so we'll need a negative 27 when we multiply these together, and a positive 4. We will now FOIL this out to see if it double checks. 2x times 3x is 6x squared. 2x times 2 will be a plus 4x. Negative 9 times 3x will be a minus 27x. And negative 9 times 2 is a minus 18. When we simplify by combining like terms, there's our expression, and it checks with the original. Our third and final problem in this tutorial is now on the screen. And it reminds us that the very first thing we should always do is look for the greatest common factor. In this problem, it's a 4x squared. Everything in that expression can be divided by 4x squared. We'll have 6x squared minus x minus 1. And now we're going to look into factoring what's in the parentheses. So we'll look at the factors of 6, and this is really nice here. We're going to look at the factors of 1. So when we go to write out these factors, it's easy to see that the second item in each parenthesis is going to be a 1. We're going to also want to use the 2 and the 3 in order to build a minus 1 in between. So it'll be a 2x and it'll be a 3x. Now we want it to be a minus in between. So we want the 3x to be minus or subtracted, and we want the 2x to be positive. Here should be our answer, but let's FOIL it out to check. I'll leave the 4x squared alone for a second as we FOIL these two other items out. 6x squared plus 2x minus 3x minus 1. Simplify by combining like terms. And that is what we had up here. And then if you really wanted to check it the full way, we could then distribute that greatest common factor. And that is the expression with which we began. This is a quick overview on how we factor quadratics in general.